Okay, we're going to look at right now, and it's kind of the culmination of a lot before we actually go into this, continue to do this, but go into the places where a lot of this embedded in the software we are going to be looking at here using basically data connections to develop a structural model. Specifically, to keep track of the sum of R cross F, or the sum of the torques and the sum of the forces. And we're going to do that by keeping track of a bunch of radial vectors and force vectors that are each matched to each other. So there'll be one radial vector for every one force vector, and they will be in 3 dimensions. Now, one can go about using any number of tools to do this, but we're going to use linking of Excel and AutoCAD. And for the most part, we're going to link them together in an active way, and it won't be as automated as it would, could, or should be based on the permissions. But we're going to point out that, albeit the field command works, we're not going to use that. We're going to use auto data extraction. And the reason we're going to do that is just some of the update links and some of the ease of getting stuff into something that we really understand, which is how to do stuff in Excel. All right. Some of you remember looking at the multi-line command recently when you just got back from a conference, and I pointed out what would be generally considered a negative of the software is that it didn't let you put the different lines onto different layers, but we could turn that into a positive by realizing that it did control color. And so that's what we're going to do as we lay out our radial vectors and force vectors. All right. We will put all of our radial vectors on layer radial, and we'll put all of our force vectors on layer force, and we will match every single radial and force vector together by a specific color beginning at color 10. So in other words, if we have a radial vector and a force vector, they each will have the color 10, the first set we have, the next one 11, the next one 12, the next one 13. And the reason why we're starting with 10 is so we avoid that kind of that issue with 09 and 08 and 07. So I'm just going to show you conceptually how that looks like here in PowerPoint. What we'll do is, if we make sure that we always, as we remember we talked about this week, that we always draw, we go ahead and draw one pair right now. Let me start with the color here. More ink colors, beautiful. I'm going to start with a color blue. So we're going to do one force pair right now. I've got this here, right? You recognize this before. That's going to be my spinny point. And we're going to think about a force that is right there. Now, albeit, right, these are going to be the same color. This time, in other words, the force vector and the radial vector, I'll do it a little thinner. Right? That is R1, and this is F1. And we know that they can both be broken up into components and whatever else, but we know that the moment of F about point A is equal to R1 cross F1, right? What about A? Now, if we're going to have more than one force on there, we can, just to keep track of it in this way, we can just use a different color. So let's use this little pink. And so our next set of force vectors, a nice force vector might be there, and what this is, of course, F2, and our radial vector here, of course, to the point of application is R2. And if we're going to keep track of another force pair, if we would, we can right again go ahead and change the color. And we can add a force here. And remember that this one would be R3 and F3. And right now you're looking at this in 2D, but in reality R1 and F1 could have an X, Y, and a Z component. So if I go back now to the blue, if I would, pens, color, I guess that's close to the blue here. Remember that this R1 can have R1 in the X, I, plus R1 in the Y, J, plus R1 in the Z, K. And my force can have F1 in the X, I, plus F1 in the Y, J, plus F1 in the Z, K. And these two things together are going to generate what we know to be pretty much a bad scratch here, that moment right here, which in this case is a positive moment because it is spinning counterclockwise. And we know that if we do that for one force, right, we'll be able to not only sum up the forces this way, but we'll be able to sum up the moments when they're all together. So if we go then switch colors again, and doing this in AutoCAD with actually for the first time I would say, or the second time, putting all the forces on the force layer and all the radial vectors on the radial layer, but then keeping track of the forces by color, by changing the color of the actual line that you're drafting. Remembering, of course, you have to draw these forces and radial vectors in the correct direction, either if you're doing it by a script file or a list file or whatever program you might be using. So if we go now, we can remember that as one area, and that is in the positive direction. And now this vector here, if we go back to the pens and get that color, I think which was someplace, I'll just go with that one, it's probably not it. And remember that this, of course, this force vector is basically this area here, which would be negative, right? And then finally, this force vector causes a moment, which is also negative. So what you would end up determining, if you were going to determine a resultant, of course, would be to add this and subtract out those two, add these forces together. And if we do that, I'll try to struggle this one. This one here is the first force vector. The second force vector, if I'm doing it, would be somewhere in the order of here, right? And the third force vector, if I go back to the pen here, color, kind of in this room, would be this force vector someplace there, which would mean our magnitude and direction would be here, and we then would have to divide this magnitude and keep this direction into our sum of the moments, and that would tell us where that resultant is. So if we do all this in AutoCAD, once again keeping track of, going here with the color here, keeping our forces on the force layer, our radial vectors on the radial layer, and then pairing every force by color, we'll be able to pull it out to Excel, and of course just do this calculation in a very simple Ceres, I guess, would be the determinant calculation. If this is the R in the X, R in the Y, R in the Z, F in the X, F in the Y, F in the Z, we'll be able to do this calculation in Excel and sum everything up. So that will, I believe, using data extraction, open you up to a world of where most programming is in terms of smartening up, if you would, a spatial data engine with a I guess a spreadsheet. Of course, the next step up is to go to an RDBMS, which in fact is what's underneath most spatial engines anyway. All right, we'll show you an example of that. It's pretty straightforward. It's using data extraction, and perhaps you can even try it yourself. Thanks for listening.